Welcome to the 15 July 2020 episode of IBM Developer Puget Sound. Topic: Git Survival on the Command Line, Part 2, Branching and Flows. Previously, we initialized our project and made a commit. A branch in Git is simply a lightweight, movable pointer to one of these commits. The default branch name in Git is master. As you start making commits, you're given a master branch that points to the last commit you made. Every time you commit, the master branch pointer moves forward automatically. There's a good example of this in the book, and I'll leave the cursor there for a minute so you can see the link to that book. It's git-scm.com. Then you just click on book and you can get to Git branches in a nutshell. Here you can see the testing branch has been made on this commit. Down a little farther, you can see that the head has been moved to testing. Testing is still on that commit. Some changes have been made and a new commit has been made, and the testing pointer is pointed at this commit and the head is pointed at this commit. We will write our flow for this lab based on some of the following examples. The idea is to document a repeatable flow for our purpose. In this case, each of these circles represents a commit. The colors represent a branch. So for example, this might have been the master branch. When two arrows come together, that represents a merge. And this represents the creation of a branch. This might have been a feature branch. And then some additions to the features, merging with develop, for example, and back. And then these represent the tags. Here's another example presented by GitHub. In this case, they're just showing a master branch and a feature branch. Little dots here allow you to click on the topic. So in this case, it's create a branch. And they talk about commits, pull requests, discuss and review, deploy, and merging. Interesting interactive diagram. Next, we'll take a look at an article by some engineers at GitHub. They're talking about Git workflow for continuous delivery here. If we scroll down a bit, they have a diagram, and you can see here they're showing what happens if you wait too long. You reach a point where your merges are very difficult, and so what they're proposing is, instead of making many commits, make a few commits, have a short time frame between branching commits and then merging back. And then finally, if you do some binging around, you'll for sure end up looking at this article in this picture. You'll see that this is one author's from many years ago idea of their project. He's showing the different branches they use and how they merge into those branches, how they tag the branches, and it's not a one size fits all. You have to build your own flow for your own organization and document it. Of course, that's the main theme of this discussion, is documenting your flow. Next, let's take a look at our flow goal for this lab. Here you can see that we have some commits, some branches, maybe a feature branch checked out for master. So our goal is to create a develop branch from the master, check out a feature branch from develop, make some commits on that feature branch, then merge the feature branch into the develop branch, and then merge develop into the master. So you can probably see from this diagram that there's one fewer branches in the diagram. So for example, if this was develop, then this would be feature, and then master would be somewhere up above here showing. So let's get started on that. Notice that we're in workspace this project, and we'll check the status of the project, and we see that we're up to date. We made all of our commits, or the working tree is clean. So our first goal is to create a develop branch from the master. Notice that the little star indicates that we're still on the master branch, but the new develop branch has been created. There's a little hint here that says that we've switched to the develop branch. We can check that. We see that the little asterisk highlights the develop branch. And now from the develop branch, we want to check out a feature branch. You can see we've created the new branch, and we'll check it out. And you can see that we're now on the calculator feature branch. The calculator feature branch is checked out, and we will reference some of the code from the unit test example and from a more complex example for a simple underscore calculator.py. This is an article about unit testing in Python with the package unit test. You can read that if you want to. It's on Stack Abuse. And I'm going to scroll down until we'll just take a quick look at the code. So here they're using unit test, and they're setting up some tests. And it turns out that these tests are listed in a gist, and I'll leave the cursor hovered over this so you can see the gist down there. This gentleman has very nicely created a working example, and we're going to just use that example. We're going to get test underscore simple underscore calculator.py from the GitHub gist. Then we're going to run the test code, and it fails. So the failure says module not found, module name, simple calculator. This makes sense because we only ran the test code, it downloaded and ran the test code. We did not provide the calculator, so it was not available. Probably should check our status. We see that we have a file that needs to be added. So we've made a change to the project. There is a failure, but we'll just, because we're in the feature branch, that should provide a commit with our new tests. I think we should make an amendment. Here you can see in the log that the head is on calculator feature and that the commit message is feat add tests. I also think we should do a git push here. That'll back up our work, and it gives us a warning, and we know that because we only have a master branch associated with our bare repository, and so it tells us that. It says fatal. The current branch calculator feature has no upstream branch. That's upstream as in the remote repository. And then it says if we want to push the branch, we need to use this git push set upstream origin calculator feature. So we'll copy that and paste it, and it looks like it worked well. And we can move on with the next step, which will be getting the actual calculator code with wget. And now we're going to run that test again. And we see now that the test is running and it's completing okay. That means the calculator code is correct and that the test code is accurately pulling in the calculator code. Our next step would be to check our status. And we see that our simple calculator is untracked. So let's add that. And we'll add a commit message here. So in addition to the commit of simplecalculator.py, we're also pushing that code up to our repository as a backup of our work. And now we can do some checking of the logs. Checking the log with a few properties. We can see our original commit that we made in the beginning of our tutorial. And then here you can see we've added tests, and with the decoration, the head is pointing to the branch calculator feature origin in the remote. Repository is also at calculator feature, and this is our last commit message. Let's remind ourselves what we're trying to do. In our flow goal, this was what we considered to be the develop branch, so we branched off from develop. We added the test code, and then here we added and it failed. We added some more code, and the tests passed. We made a commit. The next thing that we want to do is merge back into develop. By checking out the develop branch, we'll be able to merge the feature branch into develop. And we want to do that in a way that won't destroy any of the details on the develop branch. And the terminology for that is merging with no fast forward. Let's do that now. We'll check out. So to review, I'm going to do get merge, no fast forward, calculator feature into develop, and then with that message. It tells us the result, and we can check out the log file. And we can see that the shape of this graph looks quite a lot like our flow goal. So there was a feature branch and merging back into develop. And here you can see there's a feature branch and it merges back into develop. You'll also notice that master and develop are right now are the same. There weren't any changes. This was the first change on master, first commit. The only commits after that were made are on the feature branch right here. They were made on calculator feature. And then this is a merge commit, and that was made on the develop branch, but there weren't intermediate commits. So both the master and develop are the same. There's not an additional branch for that. And you should note that when you run this command, get log, this branch right here, I can't highlight it, but that branch right there is whatever branch you're on, and all the other branches are shown in relation to that. A natural extension of the branching and merging is annotated tagging, and the functionality of annotated tagging is to mark release points with version numbers, for example. There may be some other uses, but that's the one that I've seen. For example, on GitHub, if you go to the code section, you'll see that there are tags. And those tags get there by using annotated tagging in Git. So on our project, we're going to try that. We probably should merge develop into master because we only want to push a tag on the master branch. We're going to check out master, and we'll merge. Then we'll take a look at the log. And here we see we have the master branch and then the develop branch. So here's master because we're now on master. That's how I know this one is master. And this is the develop branch. And both, so the feature branch was merged with develop right here. And then develop, we just merged develop into the master branch. And now we're ready for tagging. We'll push our work to the remote repository. And we can even check the remote repository and see what it looks like now. Remember, our remote repository is in an IBM Cloud, and it's a GitLab repository rather than GitHub, so it looks a little different clearly. The network graph is shown here, and we can see our original commit, and then there was a feature that was added. We added some tests, and then we had to add the calculator code, and then here we merged the feature branch, the calculator feature branch into develop, and here we merged the develop into master. And it turns out I made some educated guesses about the merge messages. If we click on one of these dots, it'll open a new tab, and it'll show what was changed in this commit. And you can see that the change here, it shows all additions, all the lines that were added. And in fact, it was this entire file that was added. Since this is a tutorial on command line survival and we've switched to using a graphical interface, you might ask, well, how do we do this on the command line? That will be our next topic. What is the difference? Before we move on to the next topic, however, I would like to look at tags, since that's what we were just talking about, is tags. And here you'll see that we haven't added, it says, oh, this repository doesn't have tags yet. The problem is that we did not push our tags to the remote repository. So we need to do that from the command line. Simply, here we get the confirmation message that the tag has been pushed to our remote repository. And if we switch over to the remote repository and click on the tags link again, we'll see that we now have one tag that matches the tag that we created on development PC. And I suppose you can even, from here, you can even click on that commit and see all of the changes that were made. And what should be here is simple calculator, and then scroll down a little ways, and the test. Now we can discuss what is the difference on the command line. The syntax for the command is git diff, and the before commit and the after commit. So let's take a look at our log. You see that there's commit numbers here, and we can use those commit numbers in our diff command. Let's compare these two commits. So this will be the before commit, and this will be the after commit. Diff, copy that, and roger that. So this is very similar to the graphical user interface. There's plus symbols by the things that were added. So here, for example, the test file was added, and you have to use the down arrow or the page down command. It's kind of a Vim interface. And that was it. And that makes sense because that's the only thing that we added in that commit was the tests. And something that you'll notice here, this red mark indicates trailing white space in this file. The original author, where there was some trailing white space, they didn't have their editor set up to eliminate the trailing white space. So it's also possible to reverse these. It's more confusing. I'm not sure why somebody would want to do that, but let's find out what happens if we do that. And here, going backwards, we can see that we've subtracted this file. And it's just sort of the way of looking at it. And maybe we're looking at branches side by side or something like that rather than forward and back. It might make a little more sense that way. Let's say you need to go back in time to a previous commit. We'll take a look at the log, and let's just say you need to go all the way back to the beginning. For some reason you need to get there, you need to undo all these changes, or maybe you need to start here with a new branch or feature that doesn't have these features in it. So the way to do that is, well, and also let's notice where the head is. Right now the head is pointing at that commit. So we're going to check out this commit. And it gives us lots of advice. It says you're switching to that commit. You are in the detached head state. You can look around, make some changes. And if you want to create a new branch to retain the commits, you may do so now or later. And so this is exactly the case that I was talking about. And then it tells you how to do that with the get switch. And it also tells us right here at the prompt, we've done something kind of wonky. Let's look around and see what's here. You'll remember the very first thing we did is we wrote hello world, and then we started adding the test code, and then we added the calculator code. All of that is now gone, but our very first commit is still there. And you'll never guess what's in this file. Yeah, our print line. Now that's how to go back in time, so to speak, and go to a previous commit. And if we look at our log now, our log graph, you'll see that the head is moved to the commit that we selected. I think we should put the head back where it belongs. And we can see that the head is now back where we think it should be for the rest of the project. Ergo, we've been using the push command, pushing updates remote references using local references. And the way to add a remote is with the get remote add command and then a name like origin, for example. We saw that was used by default. And then there's a URL to the get repository, and that's specific to the service that you've chosen for the remote repository. So it's not, so I could do a specific tutorial on each service, but I'm not going to cover that here. However, we did look at GitLab in the IBM Cloud, and you might be wondering how we got that. Let's take a look at that. In the IBM Cloud, in the search resources and offering, you would search for tool chains, and inside the tool chains, you'll see there's various predefined options that include GitLab and an IDE and a delivery pipeline and some other services. And you can also build your own tool chain just by adding each one of these services independently. And so GitLab is what we were looking at on this project, and there's some other features here. For example, you can look at repository analytics, give you some charts, pretty charts and graphs that will tell you what's going on with the project. Here it's showing the language, number of commits per day of the month, number of commits on each weekday, and so on like that. We looked at some of these before. There was a graph. We looked at tags. So there's some various ways to break down the project. There's a wiki, snippets. I think these are like gists. It's on GitHub. If you just type in git commit without the -m for the message, it will default to an editor depending on what you've selected and what is the default for the system. On many systems, Vim is the default editor. You need to be aware that there are some Vim commands that you need to know in order to be able to complete your commit message. There is a Vim help file. You can see in the lower right corner there's also a website, vim.org, and here we're in the help overview of vimhelp.org. I could just do an example Vim in the terminal, and then you could see just a few basic commands. You might think you want to avoid using it, but it's worth knowing just the basics. For example, we want to edit Hello World. Vim enters a viewer mode. You can move the cursor around. You can move it to the end or to the home, but you won't be able to type very much. Oh, actually you can do things like if you press the X, then it puts something in there. So what you want to do is enter, get out of edit mode, and you want to enter insert mode by pressing I. And see in the lower left hand corner you can tell you're in insert mode, and there you can see that I've misspelled print. So if I take out the R and fix it, then it's magically okay. And in order to get out of insert mode, you press the escape key, and then in the lower left hand corner you'll see the colon appear. W means write. Push enter, it's written that file. And if I want to do that, let's say this was a commit message. We'd write the commit message, and then we'd write and quit, and we'd be out of the file, and it would automatically complete the commit message. Thanks for taking the time to listen to this tutorial, and this concludes Git command line survival. I hope to have you back soon for another tutorial.